In this animation, we will look at the phenomenon of time dilation. Time dilation occurs when the timing of an event, say a 100-meter dash, is measured by two observers that are in different frames of reference. One observer could be sitting in the stands, and the other could be in a plane flying overhead. The two observers will measure different times for the race. We will start with one observer being an astronaut standing still in a spacecraft traveling at a certain speed relative to the Earth. The event will be the timing of a laser beam traveling from the floor of the spaceship, reflecting off of a mirror on the ship's ceiling, and returning to a detector on the floor. Let's see what happens. From the reference frame of the astronaut, the time it takes for the laser beam to travel this distance is delta t sub 0, and it would be equal to twice the distance from the floor to the ceiling of the ship divided by the speed of light. We will now look at the same event, but from an observer in a different reference frame, the Earth. Let's see what happens in this reference frame. The observer will see the spaceship move while the laser beam travels from the floor of the spaceship to the mirror on the spaceship's ceiling. What you are seeing is the path of the laser beam from the reference frame of the earthbound observer. From this frame, the beam does not travel straight up, but rather, it moves along a diagonal path. The distance the laser travels is not d, but the length s in the picture. The length s is the hypotenuse of a right triangle formed by s, d, and l, the distance the spaceship travels. Since s is longer than d, the earthbound observer measures a longer time for the laser beam to reach the ceiling of the spaceship, as you can see from the earthbound observer's clock. After the laser beam reflects off of the mirror, the earthbound observer will see the laser reach the detector along the path S shown here. From this reference frame, the path of the laser beam is obviously longer than path the astronaut saw, and as a result, the time measured by the earthbound observer will also be longer. This is the phenomenon of time dilation. Times measured by observers outside of the relativistic motion will be longer than observers in the frame of the motion.